Today we are going to take a deep dive into CUDA programming and specifically we'll learn how to merge two sorted arrays in parallel on the GPU. We'll walk through this code line by line, understand the math and see how GPU threads work together to do the merge faster than a CPU. Here we start by including standard C headers for input and output and memory allocations plus CUDA.h for API applications. Here we define a device function called corank that means it runs on the GPU and callable only from other GPU functional kernels. The purpose of the co_rank using to given two sorted arrays A and B global positions are merged in array. Figure out how many elements come from A and B and how many positions from K before and after. That's called the co-ranking. We set the bounds. We can't take more than K elements from A and we can't take fewer than K minus M from A. We do binary search to find the I, j where I elements come from A and j elements come from B and together they make up K merged sort elements. If j outside valid range, adjust binary bounds, and if I outside valid range, adjust binary bounds. If last element from A bigger than the first element from B at split, we need favor from A. If last from B is bigger than first from A, we need from more from. Once neither condition holds, we found our perfect I, j splitted here. This is our GPU kernel. It takes two sorted arrays A and B and outputs merged in result C. Each thread gets a unique ID. Here TID is the global index of the merged array element this thread will compute. If our thread is within the merged array size, we call corank. Figure out our exactly where merged positions pulls data from. If we have exhausted B or the next A element is smaller, we take from A, otherwise take from B. This thread safe because each thread writes unique index C. Well merged two sort arrays of length each. Here A gets even numbers and B gets odd numbers, but both are sorted here. We print the arrays so know what's the going before merging two sorts. Here we allocate GPU memory for A, B and C. We send the input arrays to the GPU and we use 256 threads per block and enough blocks to cover R n plus m elements. Then we call the kernels. We copy the merged array back to CPU memory. We finally print the fully merged sort array and we free up GPU memory here. So does the parallel merge in CUDA. Each GPU thread figures out exactly which element is responsible for using crank function. Here is the crank function and writes A into merger array, no conflicts and highly parallelizable. If you liked this breakdown, hit like, subscribe and comment below. If you want GPU to cover parallel merge sort on GPU next.